Okay, now it's time for some LED magic. So let's just turn the bike on and 3, 2, 1. What? Oh, well, that's not good. Welcome back to the channel, everybody. I'm Dino. About a year ago, I decided I would upgrade my DR650's headlight bulb from the standard halogen H4 to the Cyclops H4 Ultra LED bulb. Now this bulb is much brighter than the yellowy colored halogen that comes standard. It's much whiter and it draws less amps than the original halogen did. It was a real win-win-win. So about a month ago, when I was having a bit of an issue with this turn signal pod, I had to fix a short that was in there. I thought it would be nice to upgrade these factory incandescent bulbs to new LED turn signal bulbs. You know, these things have come down in price. They're very inexpensive. I think I got 4 of them for under $25 Canadian. And while I was at it, I spent another $12 and got a dual filament bulb for my brake light assembly. Now the brake light assembly went in super easy. It's much brighter and it's instantly on whenever you touch the brake pedal or use the brake lever up at the bars, which is a great benefit when you want as much time between you and the car behind you when you touch the brakes. However, as you saw when I showed you at the beginning of this video, when I tried to use the turn signals, well, I just ended up with all 4 bulbs lighting up every time I turned right or left. It was like running lights instead of turn signals. If you've ever done any research into this or had this particular phenomenon happen on your motorcycle, it's quick to realize that any motorcycle that uses a single bulb on the dash to indicate your turn signals are on usually suffers from this issue. Now, especially older motorcycles like this DR650 that dates back to 1996, the whole wiring really is designed to use incandescent bulbs. And in fact, the turn signal circuits actually use the opposite circuit as the ground. When you turn left, it uses the right for the ground, and when you turn right, it uses the left for the ground. And LEDs just do not work in the same way that an incandescent bulb does, so you run into these problems. There are a number of solutions for this particular phenomenon. Today, I'm going to show you the choice that I made and the way that I'm going to solve this problem. So why don't you sit back and we'll have a look at what exactly is going on here. Welcome to my really basic diagram of a motorcycle turn signal system. Now again, this is similar to the DR650 or any motorcycle that uses a single turn signal indicator bulb on the dash, the one that lets you know your turn signals are on. The ones that have 2 independent lights are going to be a little different and probably aren't going to have this issue with your LEDs. For this example, let's outline the main components that you're going to see in a system like this. So right above me is your battery, this by a 9-volt demonstrated in this particular diagram. Now above that, you're going to see something labeled as ground. In the case of a motorcycle, this is your motorcycle frame or the engine housing. These are all connected to the negative side of the battery to complete the DC circuit or direct current. Now just over here to the, I guess, the right of me and the left of you would be your flasher relay. And in the case of the DR650, this is a mechanical flasher. As it heats up, it breaks the contact, and that's what actually causes the flash. We're going to need to address that further in this video. Beside that is the switch that activates your turn signals, the one that's on your bar. So it's a three-way switch. It's got a center that's neutral, and then left and right when you decide to make a turn. Now to the right of that, you're going to see two light bulbs. And yeah, these are compact fluorescent light bulbs from the house, but give me a break. This is the first time I've ever tried to do something like this. These will represent your right and left turn signal circuits. You're going to have another pair of these at the rear of the bike, but for this instance, it's not necessary to show you why you need to do some changes in your bike. It just really is your front, left, and right turn signals. Above that, you're going to see a double arrow, and this represents the light bulb on your dash, the little green one that flashes when your turn signals are on. The other thing you need to understand about DC power is it only flows in one direction, unlike alternating current, and it flows from the negative pole of the battery to the positive pole of the battery. It's not positive to negative, even though in some diagrams it will show that it's not the case. It actually pulls electrons from the negative side of the battery over to the positive side. Well, now that we know how the electrons flow from negative to positive, let's take a closer look at this diagram, and I'll try to explain how this circuitry works to make your lights flash and make the dashboard work. We'll start up here with the ground circuit. So from the ground, you'll see a green wire that runs off to my right over here. Now that wire splits into two wires and is attached to the outside of your bulb. When somebody wants to make a turn, let's say a right-hand turn, they flip that switch on the handlebars and this completes a circuit. So electrons can then flow from the green wire up through that bulb, across the tungsten filament, and then out the bottom of the bulb where there's an insulated contact for the positive side of the circuit. From here, we can follow that blue wire. Now it goes back up, then it cuts across and attaches to the switch itself. From the switch, it goes out as a red wire, attaches to the flasher, and then ultimately attaches to your battery's positive terminal. As power flows, the flasher starts to activate and will intermittently cut off power to the circuit, which causes the flashing effect of your turn signals. And that's how it works. It's pretty simple. The system just keeps opening and closing that circuit and the light flashes on and off. But how does that dash light work? Well, if you look at the top of the blue wire, you will see that there is an alternative pathway for the power to actually flow. So it actually flows up into the small bulb in that little dash on the DR650. But when you look closer, you'll realize that there is not a direct pathway to the ground circuit at all. There's a pink wire there that actually flows down to the left-hand turn signal circuit. And this is the magic of how this system works. Power actually flows through the unused left-hand turn signal and allows it to flow down the pink, through the actual tungsten filament, and then to the grounding circuit. And this allows that little light bulb to light up. Now, when you make a left-hand turn, the power actually flows the other way through that little bulb and out through the right-hand turn circuit, which isn't being used. Now, there's not enough power there to actually light up that incandescent bulb. There's not enough draw from that little bulb on the dash. But when you put LEDs into the system, it makes it really challenging for a couple reasons. One is LEDs require very, very little voltage for them to actually work. So the amount of current that's drawn through the ground circuit of the unused side of the turn signals is enough to actually light the LED that's in that unused circuit. And that's why you get all 4 lights lighting up, because of the small amount of draw they need to actually work. The second problem with most LEDs is power only flows one way through them. If you try to flow power the opposite direction, the LED won't light up. So this can create other problems in the circuits depending on what type of LED bulbs you have. Now for today, we're going to install LED bulbs, and I have a system that's going to help with the way that they work. Let's take a look at that. Traditionally, when you wanted to solve these 2 problems, the fast flashing and the 4-way flashing that's associated with just putting LED bulbs in the system, the way you would go about this is you would put resistors in line with each one of the turn signal pods. What this would do is it would simulate the same amount of amperage draw that an incandescent bulb would have. And that way it would, I guess, trick the flasher a little bit into thinking incandescents were still there, and you would get your flash rate down close to what it was when it was factory. For the 4-way flash though, well, you needed to install diodes into the system to stop that backfeed circuit through your dashboard light. And I believe it also involves grounding the system differently so it doesn't try to backfeed through the non-functioning turn signal circuit when you're trying to make a turn. Now this is all fine and well. In my opinion though, you have all these little resistors now that are in line, and when you start adding up the cost, you're going to spend about $25 for 4 resistors, and then you need the diode, which is another $15, and you need to sort of modify your wiring system a little bit. And I've said this before, I'm not the greatest person when it comes to wiring. I don't really enjoy it as much as I do just general wrenching. This led me to look around the internet to see if there was a choice, a different way to do things. And I found one that I think is both elegant, affordable, and works really well. And I want to show you that now. The solution that I found is manufactured by a company called TST Industries, and they're located in Lake Helen, Florida, down in the United States. Now, TST Industries produces a multitude of LED solutions for different power sports applications, motorcycles, and I think they even supply some for off-road vehicles if you're looking. And they really focus on solving issues like the 4-way flash issue and the high-speed flash issue. And they produce solutions that are quite often plug and play. And that's exactly what I found when I went to their website. Now, I reached out to TST Industries inquiring about their product, and I mentioned the fact that I was actually going to make a video about their products. So they were quite kind enough to send me these free of charge. If you were to buy these, they're going to add up to about $30 American, plus shipping depending on where you are in the world. However, the simplicity of these 2 products, in my opinion, make it a pretty good choice for anybody who just wants to plug and play like myself. So I'm going to give you my honest opinion on these as we go through and install them on the bike. So I'll summarize what my thoughts are at the end of the video on these 2 products. Let's take a look at these 2 products now. The first item I want to show you here is this electronic flasher that TST Industries provides. Now this replaces the old mechanical flasher that relied on amperage draw to actually work. So it has a consistent time that just works whether you use LEDs or incandescent bulbs. And this is what's going to solve our fast flash. The second component that TST Industries sent me was this. Now this is a pigtail that fits up under your fairing and in line with the wiring harness that's underneath there. I'm sure that it has a diode in there, and I'm pretty sure they probably reroute the grounding circuit so it's no longer bridging between the 2 turn signal circuits. I'm pretty confident that's what happens. Now this piece is nice, it's robust, it's protected with some shrink tubing here by the looks of it. and it should be relatively easy to install, and this will take care of that all four lights on at the same time problem. That's what I'm expecting it to do. So why don't we get the fairing off my bike, get the seat off my bike, and I'll show you where both the flasher goes and the pigtail, and then we'll see exactly how well this system works from TST Industries. Because my DR has a custom dash, we're going to jump back in time here, and Carl's going to show you how the stock fairing actually gets removed off a DR650. Now it's held in place with 3 machine screws here, and well, once you get those out, the fairing just lifts off. It's quite simple. The side covers are equally as easy. There's one machine screw that holds the side covers on, and then they just slide forward and off of the bike. This actually exposes the 2 retaining bolts that hold the seat in place, and we'll have to take that off to get to the flasher. So we'll use a 12mm socket, we'll take these 2 bolts out, and then really the seat just sort of slides down and back, and you can lift the seat off, giving you access to the under area. Now that we have the seat off, it's really easy to see exactly what's underneath here. You've got your battery, you've got your, I think, CDI module here. But here's what we're after over in the corner here. This is your flasher relay. So this is tucked in a little rubber band here, and we're just going to pop that out. And you can see it's attached with a small clip here. Basically, you're just going to push the tab in, and then you can pull the connector out. Let's see here. Get this out. Come on. Going the right way? I think I am. There we go. Okay. So it comes out, and here's the new flasher relay. Let's take a look and compare this one. You can see the clips are exactly the same. They look exactly the same under there. So I think we've got a pretty good match. Let's see here. There we go. They are a little bit of a different shape, but I don't think that's going to matter too much. So let's plug this one in, and they're keyed. They can only go a certain way. There we go. And they have a little clip on them there. So I'm just thinking this might just slip right in like the old one, just a little bit, little different. Let's see, how am I going to make this work? I may end up just zip tying this. Let's see if I can get it back in there. It's not gonna do what I want it to here. So this is a little bit of a challenge. Obviously, it's not gonna slide in the same way as the old one. And that's fine. What I'll do is I'll zip tie it down here, and it should hold okay. All right, I've got some longer zip ties here. We'll see if we can actually make these work. I'm kind of thinking I can come up through the rubber mount here. Let's see if this works. And then through that right there. And then just kind of hold it down like that. I think that'll work okay. It's still sort of rubber mounted. I'll just trim that excess off there. I think that'll work. The seat will come down. I think the seat will sit high enough that it's not going to impact that. That's my only concern, is that it's going to maybe press in there. I don't really have any extra wire here either to make that longer. Well, we'll try it like that. It still sits below the battery, so hopefully that's going to be okay. But that's one thing that I would say is different about the stock unit, is the way it fits in the harness, and the fact that it's got a 90-degree fitting on it there is one little weakness in this system. Hopefully this will work okay though. Well, as you can see, this custom dash is much different than probably your stock fairing. If If you're interested in how I made this, I have a 2-part series on this, and I'll leave a link down below in the description. So you too can make one of these custom dashes if you want. It's relatively easy, and it's a lot of fun. Underneath that cover, you're gonna find on a stock bike one of these here. This is a piece of rubber here that would fit over top of your wiring harness and sort of seal it out. Now, I don't use this because I just don't have room anymore with my LED light and the ballast that that takes up and the custom dash and everything. It just didn't work for me anymore. So I got rid of this thing and tucked it away for when someday if I sell the bike, I can reverse it back and still use that piece of protection. But underneath that cover, what you're gonna find is a mass of wiring, which may be a little bit intimidating, but what you're looking for is this. Now on mine, it's a blue connector. There's a black connector as well. But this is a 6-pin connector. And if you follow it, it'll actually lead you all the way up to that little mini dash where your neutral light is. So you'll know that that's the proper wiring harness that you're gonna switch out. These are a little difficult to get apart because there's a little locking tab here that you need to sort of push down and then wiggle it out. I find you can kind of do this. It took me a bit. I actually had this out just to see how hard it would be. You kind of wiggle it back and forth, make sure that little tab is pushed down, and then you'll see it separates quite easily. What we're going to do next is we're going to take our pigtail here and we're actually going to install it in line. Now, once again, I'm going to use some of this Grote Ultra Seal on these connections just to make sure that they're waterproof. So I'm just going to apply a little bit on the one end here. You don't need tons. And then a little bit here on the other end. This stuff's kind of messy. But basically all you're trying to do is seal that connection up so that it doesn't allow water to get in. Once that's done, all you really need to do then is take the 2 connections and push them together. Now this might take a little bit of effort. Take your time. What you want to make sure you do is line up the little hole here on top with this little pin. So they go in, and then you want to make sure that it goes all the way in and it locks down on that tab right there. We're going to follow this up by putting the next piece in. And it's just as easy. Just goes in and it locks in like that. Now it's just a matter of tidying all of the components up so it fits tight inside of that protective sheath, or in my case, just so it fits underneath the dash cleanly and I can get things put back together. Before we do that though, let's test our LEDs and see if they work. Of course, before we can actually test the system, well, we need to change the bulbs out. So I'll use this small Phillips head screwdriver here to get the 3 screws out from the back of each pod. These are just threaded directly into the amber lens, and it just pops right off when you're done. Now I just leave the 3 screws in place. Here you're going to see the actual incandescent bulb, and to get it out you're going to push it in and turn it counterclockwise. Now the goo that you see on there is dielectric grease I put in earlier. I'm going to clean all of that out with some electrical contact cleaner that will dissolve and clean out the socket. And this just helps make sure that everything works well. Once that dries, I'll recoat it with some fresh dielectric grease on the end of a Q-tip. And then I'm going to replace the incandescent bulbs with these amber LED bulbs, which are much, much brighter. The socket on these, though, is still an 1156 style socket with a single contact in the middle. And they'll just go in exactly the same way. Here, let me show you. Again, these just go in, just like a regular bulb. Push them in and twist them, and there we go. All right, let's test these. I'll turn the power on, and my neutral light works, which is great. High beam light works, even though I don't have a light, it still lights up on the dash. Now the big test. Let's see if the LEDs light up and they flash correctly. So let's start with the left one here. Look at that. It's working great. The dash light's working, and the right one's working, and the dash light's working too. And let me just check the back. Backs are working. This was a complete success. All right, I gotta button this thing up now. What are my final thoughts on TST Industries products that they sent me? Well, first of all, I would like to once again thank them for supplying those to the channel for a test and to see how they work and to show you how they get installed. It was really, really gracious of them, and I would like to thank them. Now, their Pigtail is unbelievable. To me, it is a really elegant solution to the problem of that four-way flash syndrome. It fits under the dash well. The only challenge I had is I have a lot of additional things under my dashboard, so wire management was a little challenging for me. I mean, I have an LED bulb ballast in there, I have 12 volt and USB plugs all trying to find space under my custom dash. For a factory DR, I don't think that'd be a problem at all. It'll actually bundle up nicely into that little factory wrap, and away you go, just tuck it underneath your fairing. So awesome job on that Pigtail. The flasher also worked exactly like TST Industries said. I plugged it in and it slowed the flash rate down pretty much to what factory was, whether it has LED or incandescent bulbs in it. Really easy upgrade. If I had one criticism, it would be the fact that it doesn't have a 90-degree connection like the factory flasher has. This means I wasn't able to tuck it down into the rubber support band that the factory flasher was in. However, zip tying it worked just fine. There's lots of room under the seat. It's more of an aesthetics thing for me and my OCD that it doesn't quite fit exactly the way that the factory flasher did. But again, that's a small issue and it doesn't in any way affect the performance. I hope you enjoyed today's video. And the nice thing about all of the stuff that we put on the bike today is it makes it ready to upgrade your turn signal pods if you want to do that at a later date. You can put either incandescent or LED pods on now, and it'll work just great with all the 2 upgrades that we did today. If you really liked it, please leave a comment. Let me know if I'm on the right track here. And you can always like and subscribe if you really think it's worth it, and I hope you do. Until then, well, I got a few more things to put away. Otherwise, I go incredibly crazy trying to get it all tidy. But I'm going to see you soon here, I hope, on Dino's Tinker Shed. You have yourself a great day. Bye for now.